Hello, my dear students. Last class I discussed about S-curve. Let us discuss about synthetic unit hydrograph. We have seen that if the rainfall and runoff records are available, unit hydrographs can be derived. However, in the case of ungauged rivers, these data are not available. In some other cases, the data available may be scanty. For such catchments, unit hydrographs are derived by relating the selected basin characteristics to the unit hydrograph shape. The resulting hydrograph derived from basin characteristics relationships is known as a synthetic unit hydrograph. There are several methods to derive synthetic unit hydrograph, but the one given by Cinder in 1938 is widely used. Cinder selected three parameters of unit hydrograph. The first one is base width TB, peak discharge QP, and basin lag TL as shown in figure. The equations given by him take into account catchment area, shape of the basin, topography, channel slopes, stream density, and channel storage. He eliminated all these parameters except the first two by including them in a single coefficient CT. He dealt with the size and shape of the catchment by measuring the depth of the mainstream channel by proposing the following equation for basin lag. That is, that equation is TP, or in some textbook it is written TL also, equal to CT into L into LC to the power 0.3, where TL or TP is the basin lag in hours and CT, that is a coefficient depending upon units and drainage basin characteristics, and L, capital L, distance from station to catchment boundary measured along the mainstream, and LE, that is distance along the mainstream from gauging station to a point opposite to the centroid of the watershed. You can see this is the figure, synthetic unit hydrograph, time versus discharge. Okay, this time is in T hours, discharge Q, and again it is measured 0.5, 0.75 QP and QP. Okay, this distance is W75 and this is W50. The peak discharge QP unit hydrograph of standard duration T is given by QP is equal to 2.778 Cp into A divided by TL, where QP is peak discharge in meter cube per second, A is catchment area kilometer square, Cp is a regional constant ranging from 0.56 to 0.69. Cinder adopted the standard duration T hours of effective rainfall and is given by T is equal to 2 divided by 11 TL. These are all his assumptions, okay, and he derived based on his studies. The duration of surface runoff or the base length TB of unit hydrograph is given by this equation. TB is equal to 3 plus 3 into TL divided by 24 days, where TB is expressed in hours, so it is given by TB is equal to 72 plus 3 into TL, where both TB and TL are in hours. Okay, it is found that this equation 4.74 gives unreasonably long base periods for small catchments. Some investigators recommend that a base period equal to 5 times the time to peak. So it is given by in this formula TB is equal to 5 times of T divided by 2 plus TL, that is equal to TB is equal to 5.455 times of TL. Suppose if assume the triangular shape of the unit hydrograph, then this formula is given by TB is equal to 5.556 divided by QP. Okay, then for the width of the unit hydrograph at 50 and 75% of the peak discharge, this is the width of the hydrograph. This is for 50%, this is for 75%, and then that is given by this equation, that is W50 is equal to 5.87 divided by QP to the power 1.08. If it is for 75%, W75 is equal to W50 divided by 1.75, where W50 is width of the unit hydrograph in hours at 50% peak discharge, and W75 is equal to width of unit hydrograph in hours at 75% peak discharge. QP is equal to, small qp is equal to capital QP divided by A, that is equal to peak discharge per unit area. Usually, 1/3 of this width is kept before the unit hydrograph peak and 2/3 after the peak. If synthetic unit hydrograph any other duration T is required, then the modified basin lag is given by this equation TL dash, that is equal to TL plus T dash minus T divided by 4, that is also equal to QP dash is equal to 2.778 A into CP divided by TL dash. Same this formula only to calculate the peak discharge, this equation is used. So this is about synthetic unit hydrograph. So you just remember all these formulas, what are the assumption. Main thing you have to remember this discharge formula, QP is equal to 2.778 CP into A divided by TL, and what is W50 and what is W75. Okay, now let us discuss about peak flow determination. The extreme hydrologic events are floods and droughts. All of us know this. In general qualitative terms, these refer to periods of unusually high and lower water supplies. A flood is an unusually high stage of a river due to runoff from rainfall or melting of snow in quantities too great to be confined in the normal water surface elevations of the river or stream. In the peak flow determination, reference is made to the following three types of floods. Okay, to find the peak flow, there are three types of the floods. The classification is done. The first one is standard project flood, that is SPF. It is the flood that would result from the most severe combination of meteorological and hydrological factors that are reasonably applicable to the basin. However, extreme rare combinations are excluded. Okay, this is about SPF. The second one is maximum probable flood, MPF. This includes the extreme rare combination also excluded in SPF. Thus, it is defined as extreme flood that is physically possible in a region as a result of severe most combination including extreme rare combination of meteorological and hydrological factors. It is observed that SPF is about 80% of MPF. The last one is design flood. A design flood is the flood discharge adopted for design of a hydraulic structure after careful considerations of hydrologic and economic factors. A design flood in most of the cases may be less than MPF. There may be several design flood values adopted for various components of a project. For example, design flood used for spillway will be more than the design flood used for cofferdam of the same project. So this is about peak flow determination. Three types: standard project flood, maximum probable flood, and design. The peak flood discharge in a stream may be determined by the following methods: by physical indication of past floods, by empirical flood formulae, by unit hydrograph, by flood frequency analysis, by enveloping curves, and by rational formula. So this is about the peak flood discharge. So I hope all of you understood. Thank you.